Alright class, welcome to today's lesson. Today we're going to talk about calipers, how to use them, what they are, different types. So again, agenda, types, purpose, how to read. So types of Vernier calipers, which is the technical term. This here at the very top is a traditional Vernier caliper. You'll notice there's not anything kind of special in it, whereas the next one we have a dial, which has the dial in the middle, and digital, which has the digital reading. They all have very similar components, so you'll see the internal jaws, external jaws, internal, external, same here. You've got the slide rule, or the metric scale, imperial scale, all very similar. You've got a sliding wheel controlled by a wheel. You've got a locking screw or tightening screw, clamp screw, depending on the picture. Depending on the manufacturer, they might have different information. You also have a depth measuring blade that sticks out the end. This one doesn't necessarily show it, but it should have one as well. So those are the three main types. Again, the generic version is called a Vernier caliper, dial, and then digital. So what is the purpose of a Vernier caliper? Really, it's got threefold. So measuring the internal dimensions of a void. So if you wanted to see how wide this hole was, or from here to here, you could use the internal jaws, stick those in, spin the wheel until these internal jaws touch the sides, and then read it. Again, I'll get to all that in a minute. Measuring the depth of a void, so how deep does this hole go? That's the point of the depth measuring blade. You stick it in, crank the wheel until it hits the bottom, and then you read it, as I'll explain again here in a bit. And then also for any sort of external dimensions of an object. So if an object sticks out, how wide is it? How tall is it? Same with this knob on the side. If you wanted to see how deep it was, you can also do that with a Vernier caliper. So how do you use one? So you always use the dial to open and close. If you instead try to force it open or close it, there are gears in here. You will break them. The dial, the digital, all that will stop working. So always, can't stress it enough, use the screw or the fine adjustment thumb wheel to open and close it. Again, kind of touched on this already, but you can use either the inside measuring jaws, the outside measuring jaws, or the depth blade to measure what you're looking for. Once you've got it, say you're trying to measure this void and you're trying to go side to side, once you've got it in there, you can kind of read it, but sometimes it's a little awkward to read. You'll want to lock it in place using this clamp screw. So you tighten it all the way down. You can then slide it out. This will no longer move. So then you can kind of set it down and read it. And the way you read this is pretty straightforward, but it's complicated the first couple of times. So there are 4 numbers to read on a dial or a Vernier caliper. The digital one kind of takes the guesswork out for you. So you start with the biggest number and then you work your way to the smallest decimal. So first you read the whole inches. Here on the inside of the slide, you'll see big lines, and it goes 0, 1. You want to count only if you see the line. So 0, 1, I don't see the 2, so I know here I've got at least 1 inch. Next I move to the tenths. The little bit smaller line, and the numbers that aren't elevated are tenths. So in this case I see a line for the 1, I see a line for the 2, I don't see the 3, I don't see the next line, so I know I've got at least 2 tenths. So I've got 1 inch, 2 tenths, but the purpose of this is to be very scientific, especially when I'm designing something in CAD. to fit a hole. So the next I go to the dial, I start with the hundredths. So in this case, it's where's the big 10-digit number. So 10, 20, 30. I'm past the 30. So in the hundredths place, I've got a 3. So right now I've got 1.23 inches. Now I'm looking to see where are my thousandths. 1, 2, 3, and I'm just past the 4th, not to the 5th, so I'm at 4. So in this case I'm at 1 inch, 2 tenths, 3 hundredths, and 4 thousandths, or 1.234 inches. Now I didn't really talk about this before, but let's say I was trying to make a plug to fit this hole, and say that was the width of this hole. Now that I'm in CAD, when I go to dimension my plug, I know that it needs to fit a 1.234 width. So I can do my dimension lines like we've done in the past, type in 1.234, and I know that within a tolerance, any plug that I extrude that has that dimensions and width and that general shape should fit widthwise. I would also need to know my width here, and then kind of the angle, or what the rate of change here is. So I could very quickly make a plug to fit this hole. If I wanted to, I could also then do this hexagram or this square. Same with the circle. If I measured this extrusion here, the width, the height, the depth, I could very quickly create kind of a pocket and almost, kind of like a connecting block, make a hole that this would fit perfectly in. So that is the point of a vernier caliper. That's how to read it, how to use it. So you have a project or a classroom assignment where you will actually get one of these cubes, a set of dial calipers, and there's a series of questions to answer. So go ahead and give that a try. If as you go along you have any questions, review the video, talk with your neighbor, see if they can help you, and then if all else fails, come see Mr. McDonald. More than happy to help you. Until next time, keep on giving it a try.